Alright guys, so you should be back on your note sheet now, taking a look at the picture that looks like this. So I realize mine's in color and yours is in black and white, but the picture should be the same. So let's take a look at these questions and see what they're trying to lead us to find an answer to. So first question says, what is the sign of ABC? So let's take a look. We got two triangles here. We got blue and orange. The blue triangle, ABC. We want to find the sign of theta. So theta is the angle we're looking for. So what we got to do is find that theta. Well, it is right here. And if you guys remember in SOHCAHTOA, sine is opposite over hypotenuse. So that's what I'm going to do. I'm going to say the sine of theta is equal to the opposite. So we got to come to our picture and say, okay, well, from theta, the opposite side in ABC is 6 over the hypotenuse in ABC, which is 10. So the sine of theta is going to be 6 over 10. Now we can reduce that. 6 over 10, 2 goes into both those numbers. So that's going to give us 3 over 5. So the next problem asks us, what is the sine of theta for triangle EBD? So we're going to come over here. We're still dealing with that same angle, that same theta. So we're still dealing with this angle. But they want us to find the sine of theta for triangle EBD. So the smaller triangle, the one in orange here. So again, guys, if you remember, sine of your angle is equal to the opposite over the hypotenuse. So we know that. All we need to do is then figure out what the opposite and the hypotenuse are. So we're going to say the sine of theta is equal to opposite. In this case, opposite of theta is 3, and the hypotenuse is 5. So our ratio would be opposite 3 over hypotenuse 5. Looking at these two, do you guys see any relationship between this first one for triangle ABC and the second one, triangle EBD? If you take a look, they're both the same. We got 3/5 for both triangles when we took the sine of that angle theta. Now, the reason for that is because theta is the same value in both of these triangles. So because theta is the same for both triangles, that means their ratios are also going to be the same. Because all a trig function is it's taking a look at an angle in a triangle, and if the angle's the same, that ratio comes from what that angle is. So if I was to change the angle, the ratio would change, but if the angle's the same, the ratio stays the same. So before we had fancy calculators, all they used to have is a table, and they'd have like a little chart here, and they say, okay, well, if I have 30 degrees, the ratio for sine of 30 degrees is going to be 1 over 2. And then they say cosine for 30 degrees is going to be square root of 3 over 2. And they got this table, and that table is what they would use instead of using a calculator, because every time it's 30 degrees, that number is going to be the same no matter what. And now that we have calculators, it makes it a little easier for us. We don't have to look at a table. But the same concept applies. If I have the same angle, this ratio is always going to be the same. Now let's dive in a little bit deeper. Take a look at this next question. It says, are right triangle trig ratios the same for similar triangles? So let's think about that. And let's jump back up to our picture that we have up here. So it says for similar triangles, let's ask ourselves, are these two triangles similar? So I'm going to erase all this extra writing we got here so we can take a look at it again. So if you look, similar triangles, one way to prove triangles were similar was by that angles theorem, or postulate. So the angles postulate says that if I have two pairs of congruent angles, then the triangles are similar. So if we look, we have this pair here, and then we have that reflexive property pair of angles at theta. So that means we do have two pairs of congruent angles. So triangle ABC, and triangle EBD are both similar triangles. So what we can say is, when we already shown actually, that because these triangles are similar by AA, that their ratios, their trig ratios, are going to be the same. If you wanted, we could check the cosine and tangent as well. And if you want to, pause the video, go ahead, try it out, check those ratios. You'll see that those ratios are the same for this angle theta. They're not changing. So the question is, are the right triangle trig ratios the same for similar triangles? Yes, they are. But why? Why are they the same? So if you guys remember, when we have similar triangles, that means the sides are proportional, meaning that 3 relates to 6 the same way that 5 relates to 10, the same way that 4 relates to 8. And if you look, aren't those all just times 2? Times 2? Times 2? So they have that same relationship. That's called our scale factor, right? And that relationship is that proportionality. So why does it work for every trig function? Because in similar triangles, the corresponding sides are proportional. And we're talking about the corresponding sides. Those would be our opposite sides. And we're talking about the same angle. Those sides, if we look, that 3 and the 6 are going to be opposite of theta. The 5 and the 10 are going to be the hypotenuse. They're going to be those corresponding sides. And so that means they're going to be proportional. And so that's why every trig ratio works for similar triangles, because, or that's why they're the same for similar triangles, because those sides are proportional, and a ratio is just a fraction, and proportional means equal fractions. And if we look up here, we've already shown those fractions are going to be equal for the same angles. Now I know that's a lot, but basically all it's just saying is that they work because we have similar triangles. So I could draw in another triangle here, make a little bit longer one, and change that proportion again, and I would get that same fraction every single time. I'm always going to get, if I take the sine of this theta, I'm always going to get that 3/5. If I take the cosine, I would always get the adjacent over the hypotenuse, or in this case, 4/5. So it's always going to be the same no matter what I do. So that's why similar triangles, the ratios are the same for similar triangles, because the corresponding sides in similar triangles are proportional. All right, so it's a lot. Easy concept. Just kind of remember, if you see a picture like this, the sine of this angle is going to be the same for no matter what triangle you're looking at. The cosine is going to be the same. The tangent's going to be the same. Okay? So let's take a look now at what is the key takeaway here. So key takeaway, and you guys got some blanks you got to fill in. They're filled in on my sheet already here. So the key takeaway is that the acute angle theta, in this case that's what we're dealing with, theta, is the same. So the trig functions, and I just listed those out so you can remember, sine, cosine, and tangent, ratios, so the ratios of those trig functions must also be the same. Now they could be like 10/20 and 1/2, but those two ratios are equal because 10/20 reduces to 1/2. So they may not look the same, but they will reduce to be the same. Okay, so if you need to get that down, go ahead and pause, get that down, and then continue on when you get it.